Zach, I played again. I got first place.
You did?
Yeah.
Not?
I'm built.
Built so crap.
Fiber. Yeah. Sure.
Yes.
Oh, yeah.
All right, so we are beginning complex numbers. So complex numbers is a segment of quadratics. In order to be able to understand complex numbers, it's important to be able to understand simplifying radical expressions. So that was why all of your homework assignments were due for today that involved radical expressions. So what we're going to do is quickly go over and check your homeworks. So I told you to have out your homework page as well. So let's start with that homework. Square root of 9 is 3. Square root of 32 was 2 square roots of 8. But then what you were supposed to notice is 8 breaks down further. So really 32 should have been 16 and 2. So you have to multiply this again. So it's 4 and 2. So you get 2 times 2, which is 4. So your final answer is 4 square roots of 2. What? It was due 22 minutes ago. 2 square roots of 5, 2 square roots of 10, 5 square roots of 2, 4 square roots of 5, 3 square roots of 11, 6 square roots of 3, 2 square roots of 105, 5 square roots of 11, 8 square roots of 10, 8 square roots of 11, 25 square roots of 2, 2 square roots of 17, 6 square roots of 5, 33 breaks into 3 and 11, both are prime, so it stays square root 33. And 17, 18, and 19, I just wanted you to work on rewriting. So you had square root 5 over 3, square root 1 over 6. You could have also rewritten 18 as 1 over square root of 6. That would have been another way to rewrite it because the square root of 1 is 1. 19, you could write it as 1 square root of 6 over 7. And similarly in 20, you could make it 2 square roots. And again, square root of 1 is 1. So you got 1 over the square root of 5. Okay, and then 21, you looked at the top and bottom separate. You broke 32 into 16 and 2. And you got 5 over square root of 5 over 4 square roots of 2. 22, again, you broke your top and bottom down evenly. You could have canceled these. You could write them as 2 over 2 and then cancel them. But your final answer was root 3 over root 5. 23 was 5/4, and 24 was 13. But again, in 24, you could have actually started by taking 676 and dividing it by 4 and seeing that you had that perfect square, which is also 13. Okay, and then page your homework part 2. So this was from Thursday. Okay, and then here's the bottom. What, honey?
Hey, did you do that pattern?
Okay, and then on the back. So again, any of these that you need to see extra work for. So remember, if it's even and becomes odd, you get absolute values. That's not great. Elaborate what you're asking.
Like you said, like if it was 20A, not 20A, not the values.
That one would get absolute values because it starts as an even. So the A definitely goes in an absolute value. No, that would be like if you have x to the fourth, no absolute values, or y cubed, no absolute values. Yeah, even to even is no absolute values. Odd to odd is no absolute values. But an even to an odd gets absolute values.
There were some situations where it's just that one from the square to one.
If it starts as a cube, I think, maybe that's what you're referencing. So like in 16, y cubed would go to y squared and y. So on the outside it's a y, but that one doesn't get an absolute value because it started as a cubed even though it's a y squared. Maybe that's what you're thinking? Okay, and then like 25, you could have either had double absolute values, or you could put one absolute value bar around x and y. Okay. And then your last part of your homework was on the simplifying radical expressions where we did part of it in class. So we did the top part in class, so then you had to do the bottom. So you started at 1 and went to 20 on the front. Okay. And then on the back, all of the odds were at the bottom, so all you had to do was check the evens for me. So I basically made it that the odds were at the bottom. I did want to see your work, but all you have to do right now is check the evens because the odds are at the bottom. Okay? So, hopefully you are all good with that. Now, for the warm-up on the new notes, we have the square root of 3 squared plus 4 squared. So the square root doesn't cancel the squares. You add them together first. So, it's good. I can wait for you guys to finish your conversation. Doesn't hurt me. Okay. So, again, what you have to do for 1, 2, and 3 is simplify the inside, then take your square root. So you would take 3 squared and 4 squared, square them inside, then take your square root. So for each of those first few problems, 3 squared is 9, 4 squared is 16, a negative squared is positive, 8 squared is 64, 5 squared is 25, and negative 12 squared is a positive 144. Add those numbers together, then simplify to get your square roots. So just like our previous homework problems, take your perfect squares and rewrite them as integers. If it's a non-perfect square, you find the perfect square that goes into it and simplify. Similarly with 4, 5, and 6, again, you're going to square the inside stuff or combine like terms. And simplify. Okay, so we are starting complex numbers today. Our objective is to perform operations with complex numbers. The first day is always kind of easy. It's as we progress and get into more complex numbers that things become a little bit challenging. Let's start with some definitions. So what is a complex number? A complex number is the set of numbers that consists of the imaginary and the real. A complex number is a set of numbers consisting of imaginary and real. We have the introduction of the number I. I represents the square root of -1. So in math, I is representative of a number. Imaginary numbers are any numbers that have a negative square root. Imaginary numbers are any numbers that have a negative square root. the complex numbers are made up of the real numbers. So we already know all about the reals. We've been talking about the reals for all of this school year. The imaginary part is the stuff with the eyes. So this is our real number system. This is the non-real number system, aka the imaginaries. So the reason we focus so many days on where we just were is because in order to simplify complex, you have to be able to simplify square roots. So the square root of negative 121, the first thing you do is bring out the I. So it's 121 minus 7. Then you say, okay, the square root of 121 is 11. No, it's the I. Just like here, it's like a little cursive I with a loop. Nope. The 7 just tags along. So it's 11I minus 7. In standard form, it would be negative 7 plus 11I, where the negative 7 is the real and the I part is the imaginary. Remember that anytime you have a negative under a square root, that negative turns to the I. So in example number 2, that negative comes out as an I. So then you have I square roots of 18 plus 7. You're going to simplify the square root of 18 the way we've been simplifying. So 18 is 9 and 2. So you get 9I square roots of 2 plus 7. If you have a perfect square, then your square root's going to go away. Hold on. So the square root of negative 25 becomes 5I. Because the square root of 25 is 5. The negative becomes your I plus 7. Yes. It's not under the square root, so it just sort of is its own function. I is like a variable, so i's can add to i's, but an I can't add with the 7 because they're not like terms. So the I is kind of like a variable.
Why didn't you keep like the same one?
Because the I comes outside the square root. That's the property. So the idea is that like this, so like this is equal to I. So like the minute you get rid of the negative, it became an I on the outside. What? Yes. Sorry, this one should be a 3. The square root of 9 is 3. Thank you. Yeah. God, next. Yes. This is your answer.
Now, does it have to be like that it's C's walking around?
Is addition commutative?
Sure. I don't know. I think that's what it is. We go back.
I can't. I need to move forward so you guys finish your notes so you can do your homework. Okay, number 4, 5, 6, and 7. By definition, the additive inverse is what you add to get 0. So the additive inverse is what you add to get 0. So you're going to rewrite the opposite of each term. The additive inverse of negative 7 is 7. The additive inverse of negative 9i is 9i. The additive inverse of negative 5i is 5i. So when you add these together, you would 0 for all your answers. Tomorrow we will pick up with the powers of I for your homework in that packet. You're going to be doing all the problems that don't have powers of I, so you're just skipping 1 to 4. You are doing 5 to 16. So the only ones you're not doing are 1 to 4. Sure.
Is the A, which would be the, I guess, 7 in this one, and 4? Does it have to be in the front, like no matter what?
That is considered standard form.
So then yes.
If it asks for it in standard form, yes.
Is that
Sure.
because the I doesn't have to short?
Is it worth it? There's only 2 minutes. Okay.